So I was steps we were discussing about the steps for the superposition theorem. So I told you that step 1 is consider only one independent source at a time and turn off all the independent sources. Calculate the voltage and current due to the due to that active source due to that active source only. That active source means which is on. Okay. The number second step, we will repeat the process. Okay, first step for other independent sources as well. Okay, repeat the process. For other independent sources. And third step is take the algebraic sum of the contribution from all the independent sources. Take the algebraic sum of contributions from all the independent sources. Okay, from all the independent sources. So what are the advantages of this superposition theorem? It reduces the complexity. Reduces the complexity of the circuit. And what is the disadvantage? Disadvantage, it takes more time. It takes more time because you have to turn on and turn off, means you have to solve, if there are three independent sources, you have to solve the circuit 3 times. Okay, so next let us solve a few numerical problems based on this superposition theorem. So the first problem that I will solve here, it is I will take a simple problem. Let me look at the problem first. Okay, yeah. So I'm taking a problem where I will take 2 independent and 1 dependent source. Okay. "25 volts, 20 ohm, 5 ampere, 4 ohm, and this is your 0.1 Vx, and Vx is the voltage here at this node. Vx is the voltage. So I will we have to solve this, calculate now we have to calculate this voltage Vx, okay, using superposition theorem. So how many sources are there? There are 2 sources. So we will consider one source at a time. Number 1, consider 25 volt voltage source and turn off 5 ampere current source. This is a dependent source. It will remain as it is. Okay. So suppose I am solving it. So now the circuit will become like this: plus minus 25 volt. So this is 200 ohm, 20 ohm. So this is 4 ohm, because I am replacing this 5. For turning off this current source, I am replacing it by an open circuit. So this is Vx voltage at this node or this node, any node you can say, and here the voltage is 0.1 Vx. Okay, so you can see we have 2 loops here, or 2 meshes. This is mesh 1, I1, and this is mesh 2, which is I2. So instead of using Vx, I will use Vx dash. Okay, because I am considering only this source. So Vx was when we were considering both the sources. So I know I am considering only this source, so I will label it as Vx. Okay. So if I will apply this now, KVL in this loop, so KVL, it will give me 20 I1 plus 4 I1 minus I2. Okay, I1 minus I2. So it will give me drop at in this 4 ohm resistor. But you know that this 4 ohm resistor it is connected between non-reference node and reference node. So the voltage drop in this 4 ohm resistor, it will be equal to the voltage of this node. Okay, so I can write it as Vx dash equal to 25. Okay, similarly, if I will apply KVL in this loop, what I will get? I will get, this is for loop 1. Now for loop 2, I will get Vx dash is equal to 4 I1. Okay, it should be 4 I1 minus I2. Okay, Vx dash is equal to Vx dash is equal to 4 I1 minus I2. So it is 4 I1 minus I2, but this I2 is equal to minus 0.1 Vx. So it will be 4 I1 minus I2. Instead of minus I2, I will write minus 0.1 Vx. Okay, so Vx dash will be equal to 4 I1 plus 0.1 Vx dash. You got it? So if you will solve this, you will get, from this you will get I1 is equal to Vx dash minus 0.4 Vx dash. It we will get 0.6 Vx dash by 4. So this is your I1. So you can substitute this I1 directly from here in this equation. What will you get? You will get, after solving the equation, if you will solve this equation, you will you take few steps to solve this equation, you will get Vx dash is equal to 6.25 volts. Okay, now in the second case, I will consider only 5 ampere current source and I will turn off this 25 volt voltage source. So how will the circuit becomes? Consider 5 ampere current source and turn off 25 volt voltage source. So the circuit will look like this. So how will you turn off this voltage source? Okay, by representing it by a short circuit. Okay, so if I will represent this by a short circuit, it will be 20 ohm resistor here. Only 20 ohm resistor from this to this, only 20 ohm resistor is there. Okay, in parallel with a 5 ampere current source. Now here I am saying here the voltage will be Vx double dash. Okay, so in parallel with 4 ohm resistor, in parallel with a current source of voltage 0.1 Vx double dash. Okay, so these two current sources, they are in parallel, so I can represent them by a single current source, which is equal to 5 plus 0.1 Vx double dash, and these two resistors are in parallel, so the net resistance will be equal to 20 multiplied by 4 divided by 20 plus 4. So it will be what was the 80 divided by 24, 4 8 3 are 24, 8 10s are 80. So it will be, R equivalent will be 10 by 3. So in series with a resistor of resistance 10 by 3. So what is Vx dash? Vx dash is the drop in this resistor 10 by 3. So you know that Vx double dash is nothing but this current multiplied by this resistor is 5 plus 0.1 Vx double dash, okay, multiplied by 10 by 3. So if you will solve this problem, what will you get? You will get thrice Vx double dash is equal to 50 plus Vx double dash. So if you will solve this, you will get Vx double dash is equal to 50 by 2, which is equal to 25 volt. Okay, so what will be Vx? No, Vx will be superposition theorem. It will be Vx dash plus Vx double dash. So the polarity is plus minus here, and again here the polarity was plus minus, so both will get added. So it is 6.25 plus 25. So Vx is nothing but 31.25 volts. Okay, so this was a superposition theorem problem. I have given you 2 problems. I will give you 3-4 problems more. which you people will solve, and you, after solving these problems, you will show me these problems. Okay, like I told you, maintain a notebook, a 20 rupees or 30 rupees notebook, and solve these problems on that notebook, plus assignments. You will also solve assignments on these notebooks. Okay, so the questions are, I have given you 2 questions, I will give you 2 more. One is related to superposition and another is related to source transformation. So the problem is like, this is a 5 ampere current source. This is a 5 ampere current source. Okay, and I have 2 resistors in parallel. One is 6, but one is 3 ohm. Okay, then I have a voltage source here, minus plus 5 volt. After that I have 7 ohm resistor, 5 ohm resistor, and a 3 ampere current source. Okay, so what you have to do, you have to reduce the circuit. Okay, you have to reduce the circuit. You have to give me what is the current that is flowing in this resistor, I. You have to calculate I. Okay, use source transformation or any technique which you know, but you have to solve this circuit. So the another question which I am giving to another problem, it is like, plus minus 8 volt, 6 ohm resistor, 2 ampere, 2 ohm, 8, plus minus 6 volt. You have to calculate the current that is flowing in this 8 ohm resistor. You have to solve this using superposition theorem. Superposition, and in this circuit you will use source transformation. Source transformation. So that is enough for lecture number 11 or 10. So I think which chapter was, which unit was started, which lecture was started in 11 or 10 today. So it was lecture number 10. So